Hello everyone. Today, we're going to explore FlexDashboard, a powerful package for creating interactive and responsive dashboards. Let's start. Please visit the official site of FlexDashboard. FlexDashboard is a package for creating interactive dashboards in R. It is built on top of the Shiny package, which allows you to turn your R code into a web application. FlexDashboard provides a simple syntax for defining the structure of your dashboard and allows you to add various types of content such as text, plots, tables, and more. Those are some of the key features of FlexDashboard. Let me provide a bit more information on each of these. Layout and design. FlexDashboard provides a flexible layout system that allows you to arrange content into rows and columns. It also supports other layout options such as scrolling, tab sets, and scaling of size, as well as the ability to create multiple pages within a single dashboard. Visualization. FlexDashboard provides a wide range of visualization options, including HTML widgets, data tables, and gauges. You can easily embed these visualizations in your dashboard to provide interactive and engaging insights into your data. Interactivity. FlexDashboard integrates with Shiny, a web application framework for R, to provide interactivity within your dashboards. You can include input controls such as sliders, drop-down menus, and checkboxes, and use reactive outputs to update your visualizations in response to user inputs. Storytelling. FlexDashboard supports the use of storyboards, which are a sequence of pages that tell a story or guide the user through a set of insights. You can use storyboards to create a narrative around your data, highlighting key trends and insights as the user progresses through the dashboard. This code creates a FlexDashboard with two columns. The first column contains one chart, Chart 1, and the second column contains three charts, Chart 2, Chart 3, and Chart 4. The column headers define the start of each column, and the level 3 headers, ####chart, define the individual charts within each column. In the code, the R syntax indicates that the code block that follows is written in R and should be evaluated as such. You can add R code to generate plots, tables, or any other type of output you want to include in your dashboard. In this example, there are 2 rows, and the second row has 4 chart sections. When rendered, the dashboard will display the content in 2 rows, with the second row having 4 charts side by side. Let's break it down. The 3 dashes at the beginning and end of the YAML header indicate the start and end of the metadata configuration. Title. Row sets the title of the dashboard to row. Output. FlexDashboard of Flex_Dashboard specifies that the output format should be a FlexDashboard. Orientation. Rows indicates that the dashboard layout will be organized into rows. The rest of the document is divided into 2 main sections, each represented by a row followed by a series of dashes. These rows will be displayed as separate sections in the dashboard. Within each row, there are 1 or more chart sections, represented by a header with 3 hashes. Each chart section can contain a code chunk to render a data visualization. By default, charts in a FlexDashboard are vertically stacked and resized to fit the height of the browser window. However, if you have many charts, this may lead to charts being compressed and difficult to read. To address this issue, you can use the vertical_layout option to control the layout of your charts. The vertical_layout option can be set to either fill or scroll. When vertical_layout fill is used, charts will be resized to fill the entire height of the browser window, even if that means compressing the charts. This is the default behavior of FlexDashboard. When vertical_layout scroll is used, charts will be displayed at their natural height, and the user will have to scroll down to see all the charts. This is useful when you have many charts and don't want them to be compressed. In the example, the YAML header of the FlexDashboard file specified vertical_layout scroll, which means the charts will be displayed at their natural height and the page will scroll as necessary to accommodate them. This way, all the charts will be displayed clearly, even if there are many of them. This code is an example of a FlexDashboard R markdown file with a different layout configuration, featuring a combination of columns and tab sets. Here's a brief explanation of the code. The dashboard layout is organized into 2 main sections, each represented by column followed by a series of dashes. These columns will be displayed side by side in the dashboard. The first column contains a single chart section, represented by a header with 3 hashes. The second column contains a tabset, indicated by the Tabset attribute. A tabset organizes chart sections into tabs, which users can click to switch between different visualizations. There are 3 chart sections within the tabset, each with its header and code chunk to render a data visualization. The data width and data height attributes in FlexDashboard allow you to control the relative size of rows, columns, or individual charts. These attributes determine the relative size between charts laid out in the same dimension, horizontal or vertical. By using these attributes, you can customize the sizing behavior of your charts and adjust the size of the charts to suit the nature of the charts and the desired emphasis, visualization types, etc. This way, you can ensure that your charts are displayed at the appropriate size and with the desired level of detail, and that the focus of the dashboard is clear to users. Each row has an additional attribute, data height, which sets the height of the row in pixels. In this example, the first row has a height of 100 pixels, while the second row has a height of 200 pixels. The first row contains a single chart section, titled Chart 1, with placeholder text Chart 1 here. The second row contains 2 chart sections, titled Chart 2 and Chart 3, with placeholder text This is Chart 2 and This is Chart 3, respectively. The code snippet I provided is a simple example of how to create a Flex dashboard with 2 pages. The first line defines the title of the dashboard as Page Orientation and the output format as a Flex dashboard. The first page is defined by the Level 1 Markdown header Page 1 =, and containing 2 charts. The second page is defined by the Level 1 Markdown header Page 2 =, and includes the attribute Data Orientation = rows. This attribute specifies the orientation of the content within the page as rows, which means that the content will be arranged vertically in rows. In this simple example, the 2 pages of the dashboard are defined and their orientation is specified. The first page does not include any content, while the second page is set to display its content in rows. There are several ways to include tabular data within a Flex dashboard, including using functions such as render table or render data table. These functions allow you to display data from our data frames or other sources as interactive tables within your dashboard. The tables can be sorted, filtered, and paginated, and users can also export the data to various formats, such as CSV or Excel. In addition to these functions, you can also include tabular data within a Flex dashboard using HTML tables. This allows you to control the exact layout and styling of your table, and to include custom features such as sorting and filtering. The row contains 3 value box sections, each represented by a header with 3 hashes. Each value box is created using a code chunk that incorporates the ValueBox function from the Flex dashboard package. The ValueBox function is called with 3 arguments, a numeric value, a caption, and an icon from Font Awesome. In this example, there are 3 value boxes. ValueBox 1 displays the number 42 with the caption errors and a thumbs down icon. ValueBox 2 displays the number 107 with the caption trials and a tag icon. ValueBox 3 displays the number 247 with the caption connections and a random icon. Note that the value argument in the ValueBox function sets the value displayed in the box, the subtitle argument sets the text displayed beneath the value, and the icon argument sets the icon displayed next to the value. In the gauge function, the value argument sets the value to be displayed on the gauge, the min and max arguments set the range of the gauge, the symbol argument sets the units for the value, and the gauge sector argument sets the color and label of different sections of the gauge. Thank you so much for your time and attention. We hope you found this presentation valuable. Remember, keep going and exploring new ideas. Hope to see you next time.